So, Konstantinos, welcome at the Security Bootcamp. Great to have you. Maybe for the people, a short introduction, who you are.
Okay, I'm Konstantinos Karagiannis. I'm Chief Technology Officer for BT America's Security Consulting. And basically, I spend half my time breaking into banks and the other half talking about it.
Okay, and we're extremely happy and proud that you're coming over, especially for this event. It was crowded with your session on quantum computing. Just some takeaways on where we are now with quantum computing from your side.
What's interesting is that if you look at the requirements for a working quantum computer, they've all been met. So it's very possible that lurking somewhere out there, there's a machine that can slice through public key infrastructure just like that. So it's very possible that right now somewhere is a hidden machine that can view all transactions going on over the internet.
And how does that relate then to the quantum computing stuff?
Well, that kind of machine is based on quantum principles. So how quantum computing works is it takes these principles that a particle can be both, let's say, up and down or 0 and 1 at the same time. So unlike traditional computing that has zeros and ones, we have qubits or 0 and 1 at the same time. And you can then write algorithms that let those bizarre particles do things that normal computers can never hope to do, like slice encryption really quickly.
And what can I do today with the quantum computing technology, and what can I do in 5 years?
Well, right now it's possible that there are machines working in laboratories that are able to slice through all transmissions that are going out. In a few years, it would possibly be able to have all devices enabled, have at least at some point all phone into some area where system-to-system communication is really, really secure. So sensitive transactions between banks or whatever could use quantum technology to protect themselves too.
Okay, and then if you look at it from the bad side, what are the bad guys are going to do with it?
Yeah, well, whoever gets one first, if these things are out there like they might be, whoever gets one first can view all transmissions. So if you think back to like World War II, when Turing cracked Enigma, he didn't send a press release to the Nazis and tell them that he can now read all their transmissions. Rather, they kept quiet and observed what was going on and helped them win the war faster than if they didn't have that technology. So any entity that gets a quantum computer can read all sorts of transmissions that people think are secure.
But now, this is an IT security event. We are with more than 500 people all on the security. But now I'm a consumer and I'm blunt, and I don't read too much about this. Although I would say it's such a big threat.
Yeah, it's the kind of thing where the attacks that would really succeed would be between organizations. So if someone had a quantum computer, it would be an incredible waste of time to try and pick out each individual person's transactions. They wouldn't be so necessarily interested in what you just bought on Amazon.com, for example. They would much rather try and get the bulk transmission of sensitive data between financial institutions or something like that. So that's where the initial serious protection needs to kick in. Because right now they are vulnerable. If they're not using quantum key distribution or something like that, a quantum computer aimed at those transmissions can get quite a lot of information that people otherwise think is secure. So that's where the real threat is for the typical consumer, that their information might be breached in the air like that.
Okay, thanks a lot. Good for having you.
Thank you.
Thank you.